For Chapter 9, we're going to be solving quadratic equations. In order to solve quadratic equations, we are going to be using our simplifying radical skills from before, and we're also going to be factoring again. So before we learn some of the strategies, we're going to practice some of this old stuff. Okay, so the first topic we're going to review is radicals. Remember, for us, radical is the square root sign. When you get to a different math class, you'll learn different kinds of roots besides a square root. Okay, so for this first one, the square root of 49 is what do you square to get 49? Because 7 times 7 is 49, or 7 to the second power is 49. The answer is just 7, and the answer is rational because it comes out to be a nice whole number. Okay, so for the square root of 1, is there a number I square to get 1? Oh, sure. 1 times 1 is 1. So 1 to the second power is 1, so the square root of 1 is just 1. And once you've used the radical, you don't write it anymore. Okay, so the square root of 36 is 6 because 6 to the second power is 36. Now for these next ones, these are going to be irrational. And remember, when they're irrational, we can simplify them, but we can't evaluate them as nicely as we could as when they were rational. So for the square root of 20, I don't know exactly what it is. It's not 4 times 4, it's not 5 times 5. So I'm going to simplify it by thinking of two things I multiply to get the square root of 20 such that one of them is a perfect square. So I can simplify one of them. Okay, so first let me think of what I multiply to get 20. I could do 2 times 10. Okay, now can I square root 2 or 10? I don't know the answer to either one. How about 4 times 5? Can I square root 4 or 5? I can, because the square root of 4, I know the answer to. That's 2. Okay, so I'm going to use square root of 4 times square root of 5, which is still equal to square root of 20. The square root of 4 is 2. The square root of 5 is irrational. Okay, so the 2 came out of the radical because I already square rooted it. The square root of 5 I don't know, so I leave it in the radical. Okay, let's try square root of 18. First, look and see if you know the answer. I can't think of something I square to get 18. So I'm going to see if I can think of two factors I multiply to get 18 such that one of them is a perfect square. And you don't have to list them out, but you kind of have to think about them. Okay, what if I did 3 times 6? Square root of 3, square root of 6? No, I don't know either of those. How about 2 times 9? Square root of 2? No. Square root of 9? I do know the square root of 9. So let's try square root of 2 times square root of 9. Okay, now the square root of 2, I don't know the square root of 2. It's going to stay irrational. Okay, the square root of 9 is 3. Whatever the rational answer is, that always goes to the front, even if it's in a different order. So my final answer is 3 square root 2. Because the square root of 9 was 3, the square root of 2 stays irrational. Let's try these next ones. 44. I don't know the square root of 44. So let me see if I can think of two factors. Let's see. 4 times 11. Oh, 4 times 11, I know the square root of 4. Okay, what is the square root of 4? The square root of 4 is 2. The square root of 11 is irrational, so I leave it in the radical. Okay, 50. I don't know the square root of 50, but when I see 50, remember that makes me think of 50 cents. Why do I like 50 cents? Because I can make it out of quarters. It would be, how many quarters? 2 quarters make 50 cents. 2 times 25. The square root of 25 is 5, which is why I use 25. So 5 square root 2 is my simplified answer. Okay, square root 90. I don't know the square root of 90. Okay, let's think of what I can times to get 90. 3 times 30? No. 9 times 10? Yes, I know the square root of 9. 9 times 10. The square root of 9 is 3. Square root of 10, I don't know the square root of 10. 3 square root 10 is my final answer. Okay, one more radical and then we're going to go to factoring. 175 is big, but I'm thinking I can make this out of quarters also. How many quarters are in 175? 4 for the dollar plus 75 cents, 3, so 7 quarters. The square root of 25 is 5. Square root of 7, I don't know, it's irrational. And then that's my simplified answer. Okay, next topic, factoring. And we'll review this again as we learn it. Okay, factoring, we're going to write 3 ways to factor it, and then we're going to box the correct one, even though I know some of you are very good at getting the correct one on the first try. But some people didn't get it the first time, so we'll practice it more. Okay, so n squared plus 12n plus 20, we're trying to factor it into 2 binomials like this. Because it's n to the second, I do n times n. Okay, now let me look at the last number. Now I want to think of what I can times to get 20. How about 4 times 5? And then because everything's positive, I'll put a plus. Yes, I know some of you already know that this is not correct, but we're going to make some guesses, and then we'll figure out which one's correct next. Okay, all these are going to be n times n. Okay, what else could I times to get 20? I could do 2 times 10. All positives. I could do 1 times 20. Okay, now how do I tell which one is the correct answer? Well, remember I add up the 2 factors. So if I do 4 plus 5, I get 9, but I need it to add up to 12, so that's not it. If I do 2 plus 10, I get 12, so this is the one that works. Okay, we're going to do the same thing for B. Yes, I know some of you can do this and guess the right answer the first time, but we're just reviewing this for people who had trouble the first time. Okay, so let's look at this. I'm going to make 3 guesses, and then I'll check and see which one's correct at the end. Okay, since it's I to the second, I'm going to do I times I. I'll do the same on all of them. Okay, now the last factor is 24, so I want to think of what I can times to get 24. How about 4 times 6? 2 times 12? 3 times 8? I could do 24 times 1 also. It is a positive 24. So I'm thinking plus plus, but actually because this is a minus sign, I'm actually going to make it minus minus. So then I'm going to check and see which one adds up. Okay, let's see. Now if it's going to be correct, it has to add up to the minus 11. So if I do 4 plus 6, I get 10. 2 plus 12, 14. 3 plus 8 is 11. Okay, and because it was minus minus, it did add up to minus 11. So that's my correct answer. Let's do 2 more. And yes, eventually I won't make you write out all the guesses. Okay, let's do this. Let's see, x squared, so x times x. Okay, what do I have? I have a negative 18. Let's think of what I times to get negative 18. A positive and a negative. Positive, negative, 9 times 2. How about 6 times minus 3? How about 18 times minus 1? Okay, let me see which one of these is correct. I want it to add up to negative 3. So if I do 9 minus 2, that's 7. No. 6 minus 3, that's 3. I want it to be minus 3. So I actually do have the right numbers, but I have the wrong sign. So let me change this. Let me make this a minus 6 and a positive 3. Negative 6 plus 3 is negative 3. So that's the correct answer now. Sometimes you don't guess it quite right the first time, but we just adjust it till we get it to work. Okay, one more. And then we're going to try the ones where we have to check. I know. Okay, p squared. P times p. Okay, what do I have? I have a negative 36. So what do I times to get negative 36? Positive 6, negative 6. How about positive 9, negative 4? How about positive 36 minus 1? Okay, and then I'm going to check and see which one's right. There is no p in the middle, so I need it to actually add up to 0. So let's try this one. If I do 6 minus 6, I get 0. Okay, that's the correct answer then right there. Okay, now this is the last type of factoring that we tried. It says list at least 2 ways to factor. Check the answers until you find the correct factors. Okay, so I'm going to make 2 guesses. I'm going to check them. Well, actually, I'm only going to check if it doesn't work, I'll check the other one. Okay, so 3m to the second, 3m times m. Okay, let's check. This is positive 5. So I could do 1 times 5, or I could do 5 times 1. Okay, hopefully one of these is correct. I need to check it by distributing it or by doing the box method. I'll do the box method on the first one, and then I'll do the distributing on the second one. This is the one where you picked which method you preferred. I don't mind. Okay, if I use the box, 3m plus 1m plus 5. 3m times m is 3m to the second. 1 times m, 1m. 3m times 5 is 15m. 1 times 5 is 5. Okay, let me see if this is correct. 1m plus 15m is 16m plus 5. Does that match? Oh, actually it does. This is a 16m. Okay, so I guessed it right the first time. So I did ask you to write both guesses, but since this first one is correct, you don't need to check this second one. If it was not correct, I would check the second one and see if that worked. Okay, let's try the next one. It does say list at least 2 ways to factor, but then I'm just going to check until I get it correct. 2n times n. 2n times n. Okay, let's see. It's going to multiply to 7. So how about 1 times 7? 7 times 1. It's positive, so I could try positive, positive, but in the end it's going to be a minus, minus, because it adds up to minus 9. Okay, if you like the box method, use the box method. I'm going to distribute this time for people who prefer that. So 2n to the second, 2n times 7, minus 14n, minus 1n, minus 1 times minus 7, plus 7. Is that right? No, it's not. It needs a 9. Okay, let's try the next one. Hopefully it's right. 2n times n, 2n to the second minus 2n. Is that one right? That is right. Okay, so this was the correct way to write it. Since the first way didn't work, I needed to check it the second way. If the first way had worked, I wouldn't have checked the second way. Okay, let's do one more. And I'm going to guess and check, or I'll box this time for the boxers. Okay, 7i squared, so 7i times I. Okay, let's see, what do we have? Negative 3? Ooh, okay, let's try positive 3, negative 1, positive 1, negative 3. Okay, and you could guess differently. Sometimes you get good at looking at it in your head before you start so you can see which way is going to be the one that works. Okay, 7i times I is 7i to the second, 3i minus 7i. 7i to the second, 3i minus 7i is negative 4i. Oh, this isn't the winner. I need a 20. Okay, let me try the next one. One I minus 21i minus 3. Okay, 1 minus 21 is negative 20. Okay, is that right? Let's see. It's almost right. I have a minus 20. I wanted it to be a plus 20. So I'm just going to go back and change my signs. Instead of plus minus, I will make it minus plus. And that will fix the mistake. So minus plus. And because I fixed it, I don't have to check it again. I know that now it will work.